Okay, hello. We are learning to solve using elimination. So, let's look at how we do that, and we're going to use this little fruit problem here to figure it out. All right, so on this scale on the right, I've got 5 oranges and 2 apples. So I got 2 apples and 1, 2, 3, 4, 5 oranges, and it weighs 51 ounces. On the scale on the left, I've got 2 apples and 1, 2, 3 oranges, and it weighs 37. So, what you probably noticed is that they're almost the same. The only difference is these 2 oranges here on the side. These 2 oranges are the different ones. And so the difference between the weights must be because of those 2 oranges. So we can then figure out how much an orange weighs. And once we know the weight of an orange, we can figure out the weight of an apple. So mathematically, we can do that by making this whole thing into a subtraction problem. And these things all cancel out. And what we're left with is 2 oranges equals 51 take away 37 is 14. Now, I'm going to divide that by 2 because I've got 2 oranges. So 1 orange is just 7 ounces. And then I can say, hey, if 1 orange is 7 ounces, I'll go back to my scales and I'll say, well, then 2 apples and 3 oranges, well, these are each 7. So this is really just 21 ounces. So now I know that that is 2 apples and 21 ounces. That equals 37. And I can take away my 21, take away my 21, and find out that 2 apples weighs 16 divided by 2. An apple weighs 8 ounces. And then I can go back and I can put in those weights into the 2 different situations and make sure that I got them correct. So here it would be 8 times 2 plus 7 times 5. And I would make sure that that equals 51, and it does. And in the other one, it would be 3 oranges, so 3 times the 7 ounces plus the 5 times, no, apples, 2 times the 8 ounces. And that does equal 37. So it works for both, so I know it's correct. And that is the concept of elimination. There's a couple different ways you can look and a couple different tricks as we go. So let's take a look at how those tricks start. First, we're going to look at adding, and then we're going to look at subtracting. And we're going to look at those 2 things before you guys start in on any of the actual problems. Okay, adding. So when I am adding these 2 equations together, what I'm looking for is that something is going to get eliminated. So here I have positive 5y and negative 5y. So if I take these 2 equations and add them together, that's going to leave me with 0 y's, because 5 plus negative 5 is 0. So let me do that. 2x plus 5y equals 17, and 6x minus 5y equals -9. And you add everything. So we're adding everything. 2 plus 6 is 8x. These y's go away, there's 0. And 17 minus plus -9 is what? 8. Cool. And then I divide by 8, and I figure out that x equals 1. That's half my solution. I also need to know what y is, so I can take this x equals 1 and put it back into either of the equations. I will put it into the first one, 2x plus 5y. But that was the elimination part. Now I'm just going to substitute x equals 1 back into the original equation. So want either of the original equations, and I chose this one because it was on top. So x is 1, so that means I'm going to substitute 1 for x, plus y equals 17. So 2 times 1 is 2, so I'll take away 2, 5y equals, oops, 5y equals 15. So y equals 3. Divide by 5 on both sides. Okay. So I think the answer is the 0.13. In other words, I think these two lines cross at the 0.13. Let's check. You're going to want to check all of your answers. There's lots of little mistakes to make. There's lots of algebra going on here. So you need to check your answers. So here's how you do it. You take 1 and 3 and you put it back into both equations. It is possible to get a point that will work for one equation and not the other. So let's put them in. 2 times 1 plus 5 times 3, does that equal 17? Well, that's 2 plus 15. It sure does equal 17. And 6 times 1 minus 5 times 3, does that equal -9? Well, that would be like 6 plus -15, which does equal -9. So those are both true. So I know for sure that my answer is right. The point where those two lines cross is 1, 3. So there I added the two equations together. So if you can add them together, you can subtract them as well. This one has a little multiple choice. Oops. Here we go. Now you can see what I'm talking about. This one has a little multiple choice thing to it. You won't be doing multiple choice. This is just the way they set up the practice problem. And it's a word problem, which means we'll have to read through this and set up our two equations. So let's read it. A theater club sells a total of 101 tickets to its first play. A student ticket costs $1, an adult ticket costs $2.50. All right. First of all, they sell 101 tickets. We have student tickets and adult tickets. So I'm going to define some variables here. I'm going to say S equals student ticket and adult ticket. A equals adult ticket. Okay, and there's 101 tickets, which means that S plus A equals 101. That's one of my equations. My other equation is going to involve the cost here. Adult ticket is $2.50, student ticket is $1. They made 164. So that means, I'm going to write this in blue. S Let's erase it right here. Oh, I can't erase it. It's so sad. All right, s plus a equals. No, I'm not going to do it that way. Sorry. I'm going to do it like this. This is my blue equation if I want to talk about them more clearly. All right, let's write the green equation. So s times 1, because they're worth $1, plus a times 250. Let's write that like a real equation. So 1s is just s, and then 2.5a is $2.50 for an adult ticket, and that's going to equal 164. Cool. So here we have s and s are the same. So I could eliminate them, but this time not by adding, because that would just give me 2s. I can eliminate them by subtracting. So if I subtract here, s minus s is 0 s's, so that goes away. Here's the tricky part about subtracting. This is a minus 2.5a. So everything gets subtracted. So I did the s minus s. This is subtraction here, and this is subtraction here. I normally just write the one subtraction sign over on the left. But even though there's a plus here, you're not going to add. You're subtracting. Everything, the top is getting subtracted by the bottom. So a, that's like 1a, minus 2.5 is negative 1.5. A, and 101 minus 64 is negative 63. And then I'll divide by negative 1.5. And a equals, calculator time. I almost feel like I could do that in my head. 42. Let's see. Yep, 42. Alright, so a is 42. And now I'll substitute that back into one of my equations. So I'll use the s plus a equals 101, because that's clearly the easier one to work with. Put my newfound value in there. And 42 is away. S equals 101. Take away 42. 59. Okay, so I think I have the answer, but I'm going to check it. So I'll put it in both my equations. First, does 42 plus 59 equal 101? The answer is yes. Second, does 59 plus 2.5 times 42 equal 164? Let's check it. 59 plus 5 times 42. It sure does. Okay, so both those are true, so my answer is correct. So there I did subtraction. I just want to, this example doesn't get to one of the trickier parts, so I just want to show you something. If I had an equation like 3x plus 2y equals 10 and 3x minus 2y equals 6. If I was subtracting these two equations, you have to be very careful because 3x minus 3x is 0, but 2x minus negative 2x, this is minus negative 2, or 2y. 2y minus negative 2y. That's the same as plus. That is 4y. Well, that's a really easy mistake to make. So when there's negatives in there, you have to be extra careful because you're subtracting. Everything on the bottom gets subtracted. This is 10 minus 6. This is 4. So my made up equation y equals 1. But careful with the subtraction. You're subtracting each individual thing. Watch out for the negatives when you're doing that. Okay, so on the next couple slides, you have a couple problems similar to this to work on. Oh, I ran off the bottom a little bit. Let me fix that so you can see everything. Oh, it's hard to fix. There, that's everything I wrote. Yep, so good luck on those, and then we'll look at kind of the next step in using elimination.